Hey all you cool cats and kittens. Today we are continuing our calculus honors study of optimization. This is Mrs. McKennis, and I'm going to be working in your notes packet. We are on day 4, example number 8, and today's topic is working with margins or borders. So the problem states that we have a rectangular page that is to contain 24 square inches of print. The margins at the top and bottom of the page are to be 1.5 inches, and the margins on the left and the right are to be 1 inch. What should the dimensions of the page be so that the least amount of paper is used? So I'm going to start with the picture over here, and we're talking about a piece of paper, and there's text inside the paper. So you have some kind of border. So I'm just going to make this almost look like a picture frame. And in fact, I think one of your homework problems changes the story to a photo with a picture frame. So this part inside, this is the part with the text. And the question says that the rectangular page is to contain 24 inches of print. And then they are telling us that they eventually want us to find the dimensions of the page so that the least amount of paper is used. Now, when you talk about dimensions of print and least amount of paper, we're talking about area. So you guys know from our previous questions, for example, when we worked on volume and surface area, we had 2 different metrics that we were working with. Before that, we worked with area and perimeter, 2 different metrics. Here we're working with 1 metric, area, but we're going to create 2 different equations with it. So one of my equations will have to do with the area of the text, and the other equation will have to do with the area of the paper. And we know that these are rectangular figures. So I'm going to start with the text because that is what they actually give me a metric for. So we have 24 square inches of print. So the area of this inner section, which is your print, is 24. So I need to identify some variables. You can use X and Y. I'm just going to call this width and length. So we know that the area in here, and I'll just put a P for print because it's the area of the print. Actually, I'm going to use a T for text because we're calling this one paper, and I don't want to use the same variable. So the area of my text is going to be length times width. And I also know that the area of that text is 24 square inches. So this would be 24 equals length times width. And then over here, we're going to make an equation for the area of the paper. Now, they have not given us the actual value of the area. But what they've told me is that the margins at the top and the bottom are to be 1.5 inches. Okay, so that tells us that this is 1.5 inches and this is 1.5 inches, which means if I'm calling this area over here length, then I want an expression for this length out here. So it would be my length of my text plus 1.5 on the top, plus 1.5 on the bottom. So that's going to be length plus 3 inches. And then we're going to do the same thing for the width. So the story says they want us to assume that the margins on the left and the right are 1 inch. So to the left is 1 inch, to the right is 1 inch. So I want an expression for this entire distance. So my width of my print I'm calling W plus 1 inch on the left plus 1 inch on the right, which would leave me with W plus 2. And so over here I'm going to generate my equation for area of the paper. I'll call this P, and that's going to come from my length, which now we're calling L plus 3, and then W plus 2. So L plus 3 times W plus 2. And let's kind of take it back to what they're asking us to find. They want us to find the dimensions with the least amount of paper, so the least area. So I am minimizing area. So the area of the paper is what I'm finding a minimum of. So the area of the paper formula is what I want to find the derivative of. We know finding a minimum means I'm going to set my derivative equal to 0 to find my critical values. Now at this point, my area is written in terms of 2 variables and I only want 1 variable. So I am going to use my other equation and solve for one of these letters. It's your choice. So let's say I divided both sides by L. So we would have 24 over L is equivalent to W. And now I'm going to take this expression, 24 over L. I'm going to substitute it in over here in place of W. So I'm going to bring down my area equals my length plus 3 times, and in place of W, I now have 24 over L plus 2. And I've now written my area equation in terms of just 1 variable. If you want to differentiate as is, you would have to use your product rule, and you certainly can do that. I'm going to choose to distribute this out. So I'm going to FOIL this out so that I can use my power rule instead. So as I distribute, L times 24 over L leaves me with 24. L times 2 is 2L. 3 times 24 over L is going to be 72 over L. And then 3 times 2 is 6. And I'm just going to clean this up before I take the derivative. So I have area with my little subscript of P, and 24 plus 6 is 30, plus 2L, plus, I'm going to push this L up to my numerator so that I don't have to use my quotient rule. So that would become 72L to the negative 1. And now I am ready to find my derivative. So derivative of area, I'm going to call A prime. Derivative of 30 is 0. The derivative of 2L is 2. And then negative 1 times 72 is minus 72. L to the negative 1 minus 1 is negative 2 power. I now have an equation for my derivative. I'm going to set that equal to 0. And while I'm setting that equal to 0, I'm going to push this L to the denominator and write this equation in its natural form. And now I'm going to solve from here. You can multiply both sides by L squared if you'd like to do it that way. You can move the 72 over L squared over. I'm just going to multiply everything through by L squared. So that leaves me with 0 equals 2L squared, and then my L squared here cancels, so minus 72. And at this point, it's your choice. You can factor if you wanted, or I only have one expression with an L in it, so I'm just going to solve for L. So I'm going to add my 72 over to this side. I'm going to divide through by 2. Let's get this up a little bit. And then take the square root of both sides, which leaves me with plus or minus 6. Now at this point, we would want to identify which of these critical values is in fact a minimum, because we are looking for where we have the least amount of paper, so the minimum area. So I would be plotting negative 6 and 6. But this is a great point to do a logic test, and we are working with an area metric. So let's talk about domain. Can we actually have negative numbers if we are talking about an actual length of a real life figure? We can't, which means that not only can negative 6 not be a critical value, but anything less than 0, even equal to 0, we're not going to have a length equivalent to 0, because that would not create an actual rectangle. So anything to the left of 0 is going to get excluded from my domain. And now I'm going to substitute numbers in from 0 to 6 and 6 on into my first derivative. And I'm going to go to my version before I modified it at all. So the 2 minus 72 over L squared. I'm going to substitute a 1 in here. So 2 minus 72 over 1 would be negative. And then you can plug 7, and I'm just going to plug something more extreme, like 1,000. So 1,000 squared underneath the 72 is a very small number. 2 minus that small number is going to be positive. So I do in fact have something that is decreasing and then increasing. I do in fact have a minimum there. So L equals 6 is what we're looking for. I'm going to come over and use this space over here. So I know that my length is equal to 6, but I do need to find the corresponding width. So I'm going to come over here. I'm going to drop in my length, so 24 over 6, which leaves me with W equals 4. Now this is an important point where we now have to go back and check to make sure that we have actually answered the question. The question says, what should the dimensions of the page be so that the least amount of paper is used? Well, we have just found the dimensions of the actual print or the text. That's what L and W represent. We want the length and width of the paper itself. So I really need to find what W plus 2 is and what L plus 3 is. Well, I know L is 6, so that would be 6 plus 3, which would be 9. And then I know W is 4, so 4 plus 2 would be 6. So my final dimensions here are going to be a 9-inch by 6-inch piece of paper. Okay, good luck to you guys. Remember that you can reach out to me if you're having any trouble at all. Good luck.